Okay, we're back to the paper from 2019 A-level, and this is question number 7. And it says, in a simple model, the value V of a car depends on its age, T, in years. So that means there's a proportion or a disproportion between the two, or inverse proportion between the two. The following information is available in the car. When it starts, it's at the beginning, it's worth 20,000 and its value after 1 year is 16,000. Use an exponential model to form for the car A a possible equation linking V with T. So V equals E, which is the exponential thing, and then it's going to have to be to the power T. But we don't know what the relationship is with E, so I think we're going to have to put a K in front, which is great because I love KT because that's my name. So V equals E KT. Ooh, it must also equal A to the times E to the KT. Right. Now, when T is 0, so V equals A E K to the power T, that means that 0 makes K 0 and it makes E 1. So anything to the power 0 is 1. And that means that 20,000 equals A. So we now know A equals 20,000. And now we can put that in to find the second, so that's the exponential model. Now we're going to have to find out what K is. So we know V equals 20,000 E to K, and now after 1 year, 1. So that would just be times 1. And V equals 16,000 at that stage. So 16,000 equals 20,000 E to the power K. So that means 16,000 over 20,000 equals E to the power K. Now, in order to solve this, we're going to have to ln both sides. So ln, here we go, ln of whatever 16,000 over 20,000. And then if we ln an E, that gets rid of it, equals K. So K equals, let's just do ln, where is it? So K equals ln, there it is. So ln 2, so that's 16,000 over 20,000. I know I could have just done something a lot easier than that, but there we go. Equals, so we know that K equals minus 0.22314. So otherwise it would go up. So that means that we know that the value, according to this, equals 20,000 times E to the power negative 0.223 times T. And that's our first concept of how that works. Right, the value of the car A is monitored over a 10-year period. Okay, and now we're going to work out what happens next. So its value after 10 years is 2,000. Okay, so evaluate the reliability of your model in the light of this information. So let's have a little look whether or not that gives us what we need. So if we did this, so if we did, what does V equal after 10 years? It would equal 20,000 times E to the power minus 2.23, because 10, T would equal 10. So what does that equal? Let's have a little look. So it would be 20,000 times e to the power minus 2.23 equals, oh, I don't think that's that bad. So v equals £2,150 and 57 pence, which on the whole, it's not as, it could be worse, couldn't it? Now, I don't know whether they were going to ask us to do anything else with that, but anyway, let's have a little look. So evaluate, well, I think it's fairly reliable. The following information is available for car B, and it has the same value when new as car A. Okay, so it's worth 20,000. Its value depreciates more slowly than car A. So explain how you would adapt the equation found in A so that it could be used to model the value of car B. Well, we don't want it to go down as much. So we want essentially K is going to get smaller. Or to be bigger. Hang on. So if it depreciates more slowly, so basically if it's going to go down less quickly, then K is going to be bigger. So if we did a little experiment, so if we said V equals 20,000 E, and then if we imagine it till 10 times, so if we did it minus 1.8, then let's just see what happens there. So 20,000 times E to the power minus 1.8, and that would leave us with 3,000. So that means it's going down at a slower rate. So it's going to be bigger, still negative, but a smaller negative. And that's how you model various things using E. Right, they do go on a bit, these things. Oh, okay, here we have a graph. So figure 2 shows part of the curve with the equation y equals x, x plus 2, x minus 4. So it's nx cubed, it's a cubic graph. The region R shown in shaded figure 2 is bounded by the curve and the negative x-axis. Show that the exact area of R1 is 20 over 3. So you're just looking at this bit here. And therefore you know that one end of it is 0 and the other end of it is, so it's plus 2, so that's going to be minus 2. Because we know that this crosses the x-axis at 0 for the x, at minus 2 for the x plus 2, and at plus 4 for the other one. But we don't need to deal with R2 at the moment, we're only dealing with R1. So let's take this, so let's take y equals x plus 2 and x minus 4, and let's expand the brackets because we're eventually going to have to integrate this, and integrating something like this is much trickier than integrating what I'm about to create. So it's x equals x squared plus 2x times x minus 4, which is x cubed plus 2x squared, and then minus 4x squared minus 8x. And that should be everything. So we've got, now we need to just clean up the x squareds, and then we get x cubed minus 2x squared minus 8x. And I believe that is what we should be, that's what we actually need to be differentiating. So let's form our differential. So our differential is going to run from 0, because that's where R1 is, to minus 2. And it's going to be of x cubed minus 2x squared minus 8x. So let's integrate this. So we will get 0 to minus 2. So let's up the power, so we get x to the 4 over 4. And then let's up that power, so that's minus 2x to the 3 over 3. And then minus 8x squared over 2. And do bear in mind that we don't have a c because this is definite rather than indefinite. Now, 0 is just going to give us 0 when we put it in. So we're not going to worry about that. So we're now going to put minus 2 in. And minus 2 should give us, let's have a little look. So that's minus 2 to the 4 over 4 minus, so that's 2/3, minus 2 cubed, minus, and that's going to be 4, and that's minus 2 squared. So we're going to get some interesting things here. So minus 2 to the 4 will be 16. So that's 16 over 4. I'm going to sort everything else as I go out. So 2/3. So minus 2 to the 3 is actually going to be minus 8. Okay. And then minus 4, and minus 2 to the 2 would be 4. So let's clean this up. So we've got 16 to the 4. 16 of the 4 is just 4. So that's minus 2 times minus 8 is plus 16 over 3. Then minus 16. And we're looking for a definite article here, aren't we? So that would be... I'm quite tempted to do this. So I'm going to make it, that's going to be 12 over 3 plus 16 over 3 minus 48 over 3 is 28 over 3 minus 48 over 3. And I realise I could have used a calculator, equals minus 20 over 3, which means, because it's not going to be a minus because it's an area, if you look at it, although it means it's going to be 20 over 3. So that equals, so area equals 20 over 3 units.